let's look at chapter 4 exercises. We'll starting with the multiple choice questions. For the first one, if A and B are mutually exclusive events with the probability of A being 0.3, probability of B being 0.5, then the probability of A or B will be equal to. Since we know that the two events are mutually exclusive, we know that the probability of A or B will be equal to the probability of A plus the probability of B. So all we need to do is add the corresponding probabilities. So the correct answer will be C. If probability of A is 0.68, probability of B is 0.37, and probability of A and B is 0.27, then the probability of A or B will be equal to, we simply plug in our numbers in our formula for probability of A or B. Probability of A plus probability of B minus the probability of A and B. We have all the information. Probability of A is 0.68, probability of B is 0.37, minus the probability of both of them occurring at the same time. If we do our calculations, the correct answer will be C. Now, for the third one, if probability of A is equal to 0.5, probability of B is equal to 0.6, and probability of A and B is equal to 0.3, then events A and B are. Since if we check the probability of A and B is equal to probability of A times probability of B, then the two events are independent events. Now, if probability of A is equal to 0.8, probability of B is equal to 0.65, probability of A or B is 0.78, then the probability of B given A will be equal to what? So let's see what we're looking for. I'm looking for the probability of B given A. This will be equal to the probability of A and B over the probability of A. So let's see what we have. We have the probability of A, but we do not have the probability of A and B. So this is something that we will need to find. Where am I going to find it from? You will follow the probability of A or B is equal to probability of A plus probability of B minus probability of A and B. And from this formula, if you notice, you have 3 out of the 4 probabilities. So you will solve for the unknown, which is probability of A and B. In this case, probability of A and B, therefore, will be equal to 0.8 plus 0.65 minus 0.78, which is equal to 0.67. However, we're not done. We will take this probability and we will put it for probability of A and B in our formula for probability of B given A, because this is what we're looking for. So this is going to be 0.67 over probability of A is 0.8. If you do your calculations, the correct answer will be 0.837. If X and Y are mutually exclusive events with probability of X 0.295, probability of Y 0.32, then probability of X given Y will be equal to what? So I'm looking for the probability of X given Y. The formula is probability of X and Y over the probability of Y. Now, we know the probability of Y, but we also know that these two events are mutually exclusive, which means the probability of both of them occurring at the same time is equal to 0. So 0 over 0.32 will be equal to 0. So the correct answer is D. If A and B are mutually exclusive events, then probability of A and B will be equal to 1. As we just mentioned before, this is false. The probability of A and B, given the fact that they're mutually exclusive, will be 0, not 1. All right, not 1. Let's look at the problems. An applicant has applied for positions at company A and company B. The probability of getting an offer from company A is 0.4. The probability of getting an offer from company B is 0.3. Assuming that the two job offers are independent, what is the probability that the applicant gets an offer from both companies? Since the two job offers are independent, then it's safe to assume that the probability of A and B will be equal to probability of A times probability of B. So this will be equal to 0.4 times 0.3, 0.12. So here, let me just write it down. Probability of A and B equal to 0.12. Now, what is the probability the applicant will get at least one offer? At least one offer means one or the other. One or the other. So, the probability of A or B will be equal to the probability of A plus the probability of B minus the probability of A and B. We know now all three probabilities, so we just plug in the numbers. 0.4 plus 0.3 minus 0.12. Therefore, the probability of A or B will be equal to 0.58. For problem number 2, assume you have applied for 2 scholarships, a merit scholarship, an athletic scholarship. The probability that you receive the athletic scholarship is 0.25. So probability of A equals to 0.25. The probability of receiving both scholarships, so probability of A and M is equal to 0.1. And the probability of getting at least one of the scholarships is 0.3. Probability of getting at least one means probability of A or M. One or the other, not B, M. So, what is the probability that you will receive a merit scholarship? What is the probability that you will receive a merit scholarship? So, let's see what we have. We will solve from this formula. The probability of M or A will be equal to the probability of M plus the probability of A minus the probability of M and A. So I'm looking for this probability. I'm looking for the probability of M, of receiving a merit scholarship, and I have, out of the 4 probabilities that we have in our formula, I have the 3. So once again, we will solve for the unknown. So if you were to plug in the numbers, M or A is 0.3, is equal to the probability of receiving a merit scholarship plus probability of receiving an athletic scholarship, 0.25, minus both, which is 0.1. If we solve for the unknown, we will see that the probability of receiving a merit scholarship will be equal to 0.15. What is the scholarship? What is the probability of receiving this athletic scholarship given that you have been awarded the merit scholarship? This has to do with writing the probability you're looking for correctly. So you are looking for the probability of receiving an athletic scholarship given that you have already been awarded a merit scholarship. What is the formula for this probability? Probability of A and M over probability of M. Do I have the probability of A and M? Yes, I do. Is 0.1. Probability of getting a merit scholarship, I just calculated. So this will be 0.667. What is the probability of receiving the merit scholarship given that you have been awarded the athletic scholarship? So now you're looking for M given A. So once again, this will be equal to the probability of A and M over now the probability of A. 0.1 over 0.25. So this probability will be equal to 0.4. Now, for problem number 3, the probability of an economic decline in 2020 is 0.3. There is a probability of 0.7 that we will elect a Democrat president in 2020. The probability of an economic decline or to elect a Democrat president in 2020 is 0.8. Let E represent the event of an economic decline, which in this case is 0.3. And let D represent the event of election of a Democrat president. So, probability of D is equal to 0.7. And probability of D or E, make sure you use the correct symbols, is equal to 0.8. This is what it is given to me from the problem. I'm looking for the probability of a Democrat president and economic decline in 2020. So I'm looking for D and E, basically. Right. So again, we go back to the formula that connects all four probabilities. The probability of D or E is equal to the probability of D plus the probability of E minus the probability of D and E, which is the probability that I am looking for. So probability of D or E is equal to 0.8. Probability of D is 0.7. Probability of E is 0.3 minus the probability of D and E that I'm looking for. We solve for the unknown, and once we do that, the probability of D and E will be equal to 0.2. So this is going to be 0.2. You bring the unknown on this side and this on the other side, and you solve. If we experience an economic decline in 2020, what is the probability that there will be a Democrat president? So this has to do with how you write the probability you're looking for. If we experience an economic decline, that means that this has already occurred. So therefore, D given E. This is going to be equal to the probability of D and E over the probability of whatever event has already occurred, in this case, of economic decline. So D and E, do I have it? Yes, I just calculated, is 0.2. Probability of E is 0.3. So this is going to be 0.667. Now, if we have a Democrat president in 2020, what is the probability to experience an economic decline? So now it's the other way around. E given D, which is again probability of D and E, over probability of D. So 0.2 over 0.7, 0.286. Oops, there you go. Problem number 4. As a company manager for a Clemstad Corporation, there is a 0.4 probability that you will be promoted this year. There is a 0.72 probability that you will get a promotion or a raise. The probability of getting a promotion and a raise is 0.25. So let's see what we have. We have the probability of getting a promotion, 0.4. We have the probability of getting a promotion or a raise, 0.72, and the probability of getting promotion and raise, best case scenario, 0.25. I'm looking for the probability to get a raise. So once again, we use our formula, probability of P or R is equal to the probability of P plus the probability of R minus the probability of P and R. So probability of P or R, we have it, is 0.72. Probability of promotion is 0.4. Probability of getting a raise is the one that I'm looking for, the unknown, minus both 0.25. We solve for the unknown, therefore the probability of getting a raise will be equal to 0.57. If you get a raise, what is the probability to get a promotion? Again, conditional probability. Given the fact that you have received a raise, what is the probability that you will get the promotion? So, probability of P and R over probability of R is equal to 0.25 over what we just calculated, 0.57. And this is going to be 0.439. If you get a promotion, that means the given part is P. What is the probability that you will also get a raise? R given P. So this will be equal to the probability of getting a raise and the promotion over the probability of getting promotion. So 0.25 over 0.40. And this will be 0.625. Now, for problem number 5, we have a bank has the following data on the gender and marital status of 200 customers. We have the following table, and I'm looking for different probabilities. As we mentioned before, every time you have a table, first thing you need to do is calculate the totals of every column and every row, including the grand total. So you will have 120, 80, 50, 150, and your grand total will be 200. What is the probability to find a male or single customer? So, male or single. Once again, you take the probability of selecting a male, which is 120 over 200, plus the probability of selecting a single. You go to the total of that category, 50 over 200, minus the probability both male and single. Male and single, where do they intersect? Right here, 20. So 20 over 200. So the correct answer will be 150 over 200, which is 0.75. The probability of selecting a male or single is 0.75. What is the probability of finding a single female customer? Single female customer means single and female, both characteristics, so I'm looking for point of intersection. single, female, where do they meet? Right here. So your probability will be 30 over 200.15. What is the probability of finding a married male customer? Married male, again, point of intersection. I want both characteristics, married and male. So married male right here, where do they meet? Point of intersection, 100 over 200.5. If a customer is a female, given that the customer is a female, what is the probability that she is single? So this is the probability you're looking for. So this will be equal to the probability of selecting a single female, which is 30 over 200, over the probability of selecting a female, which is 80 over 200. So the probability will be 3 over 8.375. If a customer is a male, once again, conditional probability, given the customer is a male, what is the probability that he is married? So you take the probability of married and male, so you take the point of intersection, which is 100 over 200, over the probability of selecting a male, which is 120 over 200, and your probability will be 0.833. If a customer is single, once again, conditional probability, what is the probability that she is a female? Female, given that she is single. So you take the probability of female and single, over the probability of selecting a single person. Female and single is 30 over 200. Probability of selecting a single is 50 over 200. So 0.15 over 0.25, 0.6. Now, if a customer is married, what is the probability that he is male? Given the fact that someone is married, what is the probability that he is a male? So we take the probability of male and married, which is 100 out of 200, over the probability of being married, which is 150 over 200, and this probability will be equal to 0.667. And this concludes the problems for chapter 4.